Hate to mess up your snow day, but we're going to do some trigonometry while we're off. We left off with the PowerPoint notes at some examples of a couple of strategies. We had learned the strategy of trying to make things cancel. And then we also looked at the strategy of using Pythagorean identities to do substitution to simplify expressions. So we're going to look at some other strategies in these next several problems. And then I have some worksheets for you to do for practice. So the next thing we see in the PowerPoint is the trig expression secant times the quantity secant minus cosine. The goal is to simplify it. We're looking for something algebraic to do here. And one of the things that should just sort of jump off the page is that it looks like a distributive property situation. So anytime we have parentheses that imply multiplication, distributive property will generally take us somewhere nice. So we're going to start with that approach. So secant times secant is secant squared. Don't forget your x minus secant times cosine. Not really anything at this point that I can see to do with secant square, so let's just bring it down. But in this second expression, I know that secant is 1 over cosine. So if I change secant to 1 over cosine of x, then when I multiply by cosine x, those cosines are going to cancel, and I'm going to be left with a 1. Now some of you are savvy enough that you can see secant times cosine and say, oh, those are reciprocals. And reciprocals always have a product of 1. In which case you can skip this step that I just wrote down and go straight to secant squared x minus 1. So if you see that reciprocals go to 1, you can skip that step, and I assume that you understand that reciprocals always have a product of 1. Okay, what's left has a squared and a 1 in it, which makes me think, oh, it might have something to do with the Pythagorean identity. I have a Pythagorean identity that says that tangent squared plus 1 is secant squared. And if I replace secant squared with tangent squared plus 1, and then bring down the minus 1, then the 1's are going to add up to 0, and I will be left with a simpler expression, tangent squared x. Once we get down to a single trigonometric expression, there's really nothing else we can do. That's how we know we're finished. So that one is simplified. The next example, we have more parentheses. It should just scream at us, do distributive property. So we're actually going to FOIL this one since we're multiplying binomials. So secant times secant is secant squared of theta. Outer terms, secant times negative 1 is negative secant theta. Inner terms, 1 times secant is positive secant theta. Last times last, 1 times negative 1 is minus 1. Middle terms are going to add up to 0. Now, if you could see that before, if you notice that this is a sum and a difference, and you know that the middle terms are going to just go away, then you might just skip to secant square theta minus 1 as your first step. So if you can see it, at this point, you should be able to skip that step. Secant square minus 1 looks familiar. We had that same expression in the previous problem. And we found out that if we replaced secant squared with tangent squared plus 1, the plus 1 and the minus 1 will add up to 0, go away, leave us with tangent squared theta. Alright, so when you see parentheses, a good strategy is often to distribute and just see where it goes. Alright, on to the next one. More parentheses. Parentheses screams distribute me. So tangent times, and you've got to be really careful here. Cotangent times cosine is a single term. There are not two terms there, no pluses and minuses between them. So you only get to multiply that by tangent one time. So that's going to give us tangent x times cotangent x times cosine x. So it's just a three-factor product there. Plus, then we multiply tangent times sine. Alright. Now we have several things in the first term, couple things in the second term, and what I'm thinking is that if I could get some things to cancel, I'd have a simpler expression. One strategy is to change everything to sines and cosines, which might work for doing something with the second expression. The first factor, if you know that tangent times cotangent is 1, then you can just go ahead and make that a 1. Or if you want to actually see the work, you can say tangent x times 1 over tangent x, or change them to sines and cosines and cancel. Multiply by cosine x, and the tangents will cancel, and we'll know just to bring down a cosine. The second expression, if I change tangent to sine over cosine, well, unfortunately, nothing's going to cancel, but it might still lead me somewhere helpful. So I'm going to just go ahead and bring down what's left, so everything canceled except cosine in the first expression. In the second expression, I've got an understood 1 under the sine. If I multiply straight across, I have a sine squared x over cosine x, which really doesn't look that much better than what I started with. So now I need a new strategy because I don't really know where to go from here. So I notice that I'm trying to add two things together, and in order to add two things, particularly fractions, I need a common denominator. And it turns out that that's a really great strategy with trig functions. If we can get common denominators, we can almost always combine some terms and get something good out of it. So in order to combine these two terms, they both need cosines in the denominator. So I'm going to multiply the one on the left by a form of 1, cosine over cosine, because I need a cosine in the bottom. And remember, this cosine is over 1. If I multiply straight across, I get cosine squared over cosine plus sine squared over cosine. And I already see something happening that's going to be helpful. When I add these two fractions together, I'm going to get a Pythagorean property in the numerator. Alright, so add the numerators. Put those over the common denominator of cosine x. The numerator is equal to 1 by the Pythagorean property, so we get 1 over cosine x. And then we have a reciprocal property that says that that's equal to secant of x. So that's my simplified answer when I'm all finished. So a new strategy, if you have two terms and you only want one term, add fractions, which implies having a common denominator. Alright, let's knock a couple more out in this video. On to the next one. Alright, so there's no parentheses here, no multiplication to do, so distributive property isn't helpful. And I've got a cube, which is kind of odd. We don't have any properties just yet with cubes in them. So I'm going to need a new strategy that I've not seen before. And one great strategy for algebra and trig functions in particular is that if we have something common to both terms, sometimes it's helpful to factor it out. So because there is a common factor of sine x here and sine x here, maybe if I factor out a sine x, I'll get something useful. So sine x times sine squared x is equal to sine cubed plus sine x times, I need a cosine squared x to give me the second product. And then the nice thing that happens is the expression in parentheses is a Pythagorean property. We know from that property that it's equal to 1. So this is really a sine x times 1, which is just sine of x. So that one looked a little more complicated, but it turns out to be quite easy. So we're looking for algebraic things to do, common factors. If you see the same thing in every term, that's a great way to start a problem, see where it leads. All right. And if I'm going too fast, you can rewind, replay, slow it down, pause. All right, so next example. Again, there's a cosecant squared in this term and a cosecant squared in this term, which is a great problem for factoring. So common factors, often it will help to pull those out. So we're going to pull out a cosecant squared x. That's going to leave behind a 1 for the first term, minus, if we pull a cosecant squared out of the second term, it's going to leave a cosine squared behind. Now, if you're really savvy, you might already know that 1 minus cosine squared is equal to sine squared. If you manipulate the property, Pythagorean property. If that's not real obvious, you might want to show a step to get there. 1 is the same thing as sine squared x plus cosine squared x. So we could replace the 1 with what it's equivalent to from the Pythagorean property and bring down the minus cosine squared. And the cosine squareds will add up to 0. That's going to leave a cosecant squared x times sine squared x. And again, if you can get from the first step to the third step in a single step because you already know that little shortcut, that's great. Now I have just multiplication. So I'm going to go back to the very first strategy that I learned, which was if you have just multiplication, it's often helpful to try to find things that will cancel. And I have a property that says that cosecant is the same thing as 1 over sine. So if I change cosecant squared to 1 over sine squared x, which I can do because this is just multiplying 2 sines together, this is multiplying 2 cosecants together, and multiply by sine squared. Sine squares will cancel and leave a 1. Okay, so everything we've done so far, we've not really known where we were going. The instructions just said simplify the expression, simplify the expression, simplify the expression. So we don't really know where we're going until we get there. Fortunately, sometimes we know where we're going. So from here on out, the examples are not just going to show us where we're starting, but they're going to show what we're going to start with and where we're trying to go with it. Because sometimes we're trying to go to something that's different, but not necessarily looking a whole lot less complicated. And so since my video is almost 13 minutes long, my limit is 15, I'm going to go ahead and stop here. And in the next video session, we will pick up how to do these next few problems.